In this video we're going to look at the gradient and the y-intercept of lines. So first thing we're going to say is gradient which has a positive gradient move up as you move from left to right. So you can see here this line moves up as I move from left to right, this one moves up as I move from left to right, and this one moves up very slightly as I move from left to right. The steeper one would have a bigger number representing its gradient, and the smallest one would have the smallest number representing its gradient. This is a negative gradient. So a negative gradient, the line slopes down as I move from left to right. It slopes down as I move from left to right, and the small one slopes down as well as I move left to right. We're going to talk about our gradient as being m, and the reason for this is we will see in the next video that the general equation of a straight line, we're going to call it y equals mx plus c, where m represents the gradient. Okay, mathematically, the gradient is defined mathematically as the change in the y-coordinate divided by the change in the x-coordinate. So can we just add into this, if 2 points are x1, y1, and then x2, y2, then we'll just say the gradient is equal to, we'll just say y1 minus y2 divided by x1 minus x2. And or the way I say that, it is a y diff, which stands for the y difference, over the x difference, and that's probably what I'll be talking about in this video. So here we've got 3 or 4 ways of doing it. If you get your 2 general points, x1, y1, x2, y2, your gradient is y1 minus y2 over x1 minus x2, which is the same as a y difference over the x difference. Or you've got your gradient as your change in your y coordinate over the change in your x coordinates. And also, perhaps the easier one, which you may have seen before, is a gradient is equal to your rise over your run. So how much you go up divided by how much you go across. Okay, 2 examples here on these. I'm going to use the really easy method, which is our rise over run, and then we're going to look at our other way of doing it, which you may not be able to do all the time, and that's why it's important that we understand that you can't always do rise over run, only if you've got a diagram. So in this one, it says find the gradients of the line segments between the following pairs of coordinates. To do this, what we can do is just make a wee right angle triangle, and then we can easily work out what the rise and the run is. So we'll do the rise first. So from here to here, it goes from 2 up to 6, so my rise is 4. And then horizontally, it goes from 1 up to 4, so my run, this bit, is equal to 3. So we could say my gradient is equal to rise over run. So in this case, it's equal to just 4 over 3, and you could write 4 over 3 as 1 1/3. Or I'm going to say my gradient is equal to, and this is the way I prefer to do it, to be honest, y difference over my x difference. So in this case, my y values, I'm going to start with my b. So my y value of b is 6. My y value of a is 2. My x value of b is 4. My x value of a is 1. So that becomes 4 over 3, which again is 1 1/3. Okay, same idea in this example. We're going to do the rise over run method, and then we'll do the proper method. Now this, even in this one, I would prefer to use what I've just called the proper method. I didn't mean to say the proper method, just the other method. But the rise in this one is a wee bit, and the run is a wee bit trickier. So my rise, I'm at 4 here, and I go down to 2. So my rise really is I've gone down 2, so it's -2 really. My run is I'm at -2, and I go up to 5. So from -2 to 5 is 7. So I could say my gradient in this one is my rise over run. And in this case, that's -2 over 7. And that is it, -2 7ths. There's nothing else we can do. Or my preferred way of doing it is my gradient is equal to my y difference over my x difference. And you just have to be very careful here with your positives and negatives here. in these questions. So I'm going to start with my my D, my point which is called D. I'm going to start with it. Its y value is 2. The y value of the other point was 4, so it's 2 minus 4. And then my x value of D is 5. My x value of C is minus 2, so it's minus 2. So just be careful in this. 2 minus 4, sorry, is going to be minus 2. And 5 minus minus 2 is the same as 5 plus 2, which becomes 7. So you can see both ways I've got minus 2/7 when I have worked it out. Okay, part C, what you could do in this question is you could do a sketch out, and you could use your rise and your run method. So plot your coordinates and use your rise and run method, but that really is an awful lot of time to do that. So definitely better to use your second equation. So in this one, just say gradient equals y difference over x difference. Now in this one, I'm going to start with this one here. So my y value of the f is minus 4. My y value of e is 0. My x value of f is minus 3. My x value of e is 5. So it's what you've got is minus 4 minus 0 over minus 3 minus 5. So we'll just work up here and continue on with this. That works out to be minus 4 over minus 8. And minus divided by minus is a positive, and 4 divided by 8, that just becomes 1/2. So my gradient is equal to 1/2. Okay, I'm going to do that same question again, but I'm just going to do it a slightly different way. I'm going to use the same formula, y difference over x difference. But I'm just going to show you that you could have used, I started with f, I'm going to start with e this time. So as long as you start with the y bit of e on the top line and the y and the x bit of e on the bottom line, it should get us the same answer. So let's see if I'm right on that. So my y value of e is 0. My y value of f is minus 4. My x value of e is 5. My x value of f is minus 3. So it's a wee bit trickier maybe with the double negatives and so on. I have 0 minus minus 4. Minus minus 4 means plus 4. And 5 minus minus 3 is 5 plus 3, which is 8, which then becomes just 1/2. So you can see I could have done it that way as long as I'm consistent. So in both cases, just to show you here, folks, these two values here are my two bits from f. So I've started with them. Then in this one, I've started with my 2 bits from my x value and my y value from e. So as long as you're consistent, you will be okay. Okay, this example 7 says the line AB has a gradient of 2. The points A and B are 1, 3 and 3y. Find the value of y. Okay, right, I definitely need to use my formula to do this. So I'm going to write down my formula and then I'm going to fill it in and see what I have. So I'm just going to say gradient is equal to, and I'm going to use the longer version of the formula, y1 minus y2 divided by x1 minus x2. And this is what mathematics is all about. We don't know how to get to the answer, but we know how to get started. So we're going to fill this in as much as we know. So the first thing we can see is the gradient is 2. So instead of writing a GRAD, I'm going to write 2 is equal to in a big horizontal line. And I'm going to say, use this as my first point. So its y value is just actually y. Its x value is 3. And then for this one, my second point, the y value is 3. And the x value is 1. So that's what we have. Okay, that is a bit of a mess. So I'm going to tidy that up. So I'm just going to write that as 2 is equal to, horizontal line, y minus 3. And the bottom line is 3 minus 1, which is just 2. Okay, we are now into a situation where we have got a linear equation. So let's look at what's happening here to this y. Y is being, you're taking 3 away from y, and then what you're doing is you're dividing that whole thing by 2. So that's why it's important that you've got a nice big horizontal line here to show that y minus 3, the whole thing, is being divided by 2. So the opposite of dividing by 2 is multiplying by 2. So when this 2 moves across this side, it's going to multiply. So you're then just going to say 2 times 2 is equal to y minus 3, which just becomes 4 is equal to y minus 3. And I'm going to move up here again just to see. And then this, what's happening now? We've got 4 is equal to y minus 3. So 3 is being taken away from y. When that 3 goes across the other side, it will now add. So you'll have 4 plus 3 is equal to y. And you've got your answer. Y is equal to 7. And that is what I was looking to get. Okay, we're on to our last bit of notes for this video. It's on the y-intercept and c. And again, why this is called c. The general equation of a straight line is y is equal to mx plus c, where that is your gradient, m is your gradient, and that is your c is your intercept. So just accept that's what it is. Y equals mx plus c, m is your gradient, and c is your intercept. In this question it says the intercept value is where a line crosses the y-axis. So in this one here, you can see your line crosses your y-axis at the point 3. So on the y-axis, that coordinate would be 0, 3. So we say that c is equal to 3. The position of the intercept is always 0, c. So it's always going to be that. So if we know both the y-intercept and the gradient, we can produce a sketch of your line. So in these examples here, we've got 3 examples. And we just have to sketch them. Not great that we're sketching them on the same line. To be honest, it would probably be better doing it in 3 separate lines, but we'll have a go with it. It says here, sketch the lines with the following. So the gradient is equal to 2. The intercept is at 4. The next one has a gradient of 5 and an intercept of minus 2. And the last one has an intercept of 6 and a gradient of minus 3. What I want you to do first of all is mark on the intercepts. So the first one, the intercept is here. That would be c is equal to 4 for the first one. So we have an intercept at 4, at 6, and at minus 2. So these are just sketches here, folks. So let's mark on where 6 would be. That would be 6. Then we'll have 4. It's very roughly going to be here. And then the last one was at minus 3. So again, these are very rough, minus 3. So mark on your intercepts first. And then we'll look at our line A. So line A is gradient is equal to 2. Intercept is at 4. So it has a positive gradient. Oh dear me, I've missed it completely. There's my first line. We'll say this was A. And this will be in our next video, but can we just put it into our notes at this stage? That would be y is equal to, the gradient is 2, so 2x plus 4. Okay, my second example in part B, my intercept is actually minus 2, not minus 3, so we'll get rid of that. Oh, sorry, that should be minus 2. And the gradient was 5, so it has a positive gradient. Also, the gradient here should be steeper than the line that you've just done in part A, so make it a much steeper line because the gradient is 5. Okay, so this is my line. This is part B. So this is y is equal to 5x minus 2. So that's roughly what it should be. So yours should be straight lines. I know mine aren't. Apologies, but it should really be straight lines. Use a ruler. Very hard to use a ruler in this. So there's your part B. Y is equal to 5x minus 2. And part C, it has the m is minus 3. It goes through C on the y-axis. So it goes through your 6 is your C and your y-axis, your intercept. So it's a negative gradient. So it's going down like this. And that is going through 6 on your y-axis. So that's your part C. So that's y is equal to minus 3x plus 6. And again, we'll see more about this when writing the equations for these lines. We'll see more about these in the next video.